Welcome back. Here we're going to talk a little bit more about complex numbers, and we're going to introduce what's called the trigonometric form of complex numbers. And you're going to see that writing complex numbers in different forms is often very beneficial for certain operations we do with them. So first of all, notice that I've got, this is my imaginary axis here, this is my real axis. So we're in the complex plane. And I have here a complex number being represented by the tip of this triangle. Okay, so that is the complex number a plus bi. And notice, you can see in the diagram that you go right a in the real number line direction and up b in the imaginary number line direction to get there. So that number is a plus bi. So when we write a plus bi, or we write complex numbers in a plus bi form, that's called standard form. That is standard form. Now, standard form has some benefits, but we'll see that it also has some drawbacks. And so, therefore, we're going to use trigonometric form, which we're going to introduce in a second. Notice up here on the left I have that r is equal to the absolute value of a plus bi. In other words, it's just the distance that a plus bi is from 0, and you can see that in the diagram. So, how do we write this in trigonometric form? Well, remember, trigonometric form utilizes the angle that the complex number is making in standard position and the distance from the distance the complex number is from the origin. In other words, the absolute value. So, to make that clear, let me just show you how we can substitute the a and the b here in standard form with r and theta expressions. So as usual in the diagram we see that the sine of theta is equal to b over r, which implies, multiplying through by r, that r times sine of theta is equal to b. And likewise the cosine of theta is equal to a over r in the diagram, which implies that r times cosine of theta is equal to a. And so therefore, if we replace the a and the b here with what we found them to be equal to, we get this expression here. So instead of a, I'm going to put r times cosine of theta, and instead of a b, I'm going to put r times sine of theta. And then the I here at the end. Now, just so you know, we don't usually leave a trigonometric form like this. It tends to be written with the r factored out. So the r factored out, and we tend to like to write the I in front of the s. So we tend to move this I to be in front of the s in the sign. So plus I times sine of theta, and that's just a convention. So this here is trigonometric form. This is trig form. Okay, so for trig form of a complex number, we just need to know r, or in other words the absolute value, the distance from the origin, and the angle that's made with the complex number in standard position. So we'll be using both of these just as an example. You know, in standard form, for instance, if I have the number 1 plus 2i, that's in standard form. And let me give you an example of I'll give you another one actually too. 0 plus 3i, which often we would just write as 3i. That's another example. And for trig form, you would see something like 3 times cosine, for example, 3 times cosine of 20 degrees plus I times sine of 20 degrees. There's an example. Alright, so they all tend to fit that form. And again, we'll see the benefits of trig form later.